Hi, this is Coach Dorf. Let's continue with our trig overview. We've talked about the sine function and the cosine function and a little bit about the tangent function. Let's talk about all these different trig functions. We had the cosine of an angle, and we talked about the sine of an angle in the previous video. We can also talk about other trig functions, and these include the tangent function. Now, we talked about the tangent in terms of the right triangle, that it was the opposite over the adjacent. There's a relationship between the tangent function and the sine and the cosine function. And this is a more common way to talk about tangent functions when we deal with calculus. So the tangent is actually the sine of x over the cosine of x. We also have the secant function, so secant x. So that's written as, the complete word is secant. And when we cite tan x, that is the tangent function, so it's called tangent. The secant x is 1 over cosine of x. There's also the cotangent of x, so this is the cotangent function, and the cotangent is going to be the inverse or the flipping of the tangent function. So that's going to be cosine of x over sine x. And the last one is the cosecant x, which is the cosecant function, and it's going to be 1 over sine of x. So let's look at an example of how a problem may come about. Suppose we need to find or determine the value of the tangent of 7 pi over 6. So what do we know? Well, we know that the tangent of x is the sine of x over the cosine of x. So we need to find the sine of 7 pi over 6 and the cosine of 7 pi over 6. Now, how do we find these? Well, the first thing we do, just like in the last video, at the end of the last video, what quadrant is 7 pi over 6 in? That's the first question we ask ourselves. So here's my axis. There's x-axis, y-axis, and inside here I'm going to draw my unit circle. And now where is 7 pi over 6? Well, I know this is going to relate to pi over 6, right? Because I've got a 6 in the denominator. So 7 pi over 6 relates with pi over 6. Where's pi over 6? Well, pi over 6 is here in the first quadrant, is right there, pi over 6. So let's look at the other multiples of pi over 6. So there's 2 pi over 6, which is the same thing as pi over 3. 3 pi over 6, which is the same thing as pi over 2, which is straight up. 4 pi over 6, which is the same thing as 2 pi over 3. 5 pi over 6, which is this one. 6 pi over 6, 7 pi over 6. 7 pi over 6 is in the third quadrant, and we know in the third quadrant, x is less than 0 and y is less than 0. So my sine is going to be less than 0 and is going to be negative, and my cosine at 7 pi over 6 is going to be negative. Let's work these out. So the sine of 7 pi over 6 is going to relate with the sine of pi over 6. But remember, so the sine represents the y value, and so the sine of 6 pi over 6, its y value is the height above the x-axis. The sine of 7 pi over 6 is its height below the y value is below the x-axis. Also, sine of pi over 6 is positive, but sine of 7 pi over 6 is negative. So to make them equal to each other, I have to have a negative sign here. But they'll have the same numerical number if I were to ignore the plus or minus signs. 7 pi over 6 is equal to the negative of sine of pi over 6. And what is the sine of pi over 6? Well, remember in the last video, we had that chart, and the chart for that, we had the sine of pi over 6 was 1/2. So here we get negative 1/2. So the sine of 7 pi over 6 equals negative 1/2. How about the cosine of 7 pi over 6? How do they relate? Are they the same sign or different sign? Well, the cosine of pi over 6 is in the first quadrant. It's a positive sign. The cosine of 7 pi over 6 is in the third quadrant, so it has a negative sign. So it's also going to be a negative. So the cosine of 7 pi over 6 equals the negative of cosine of pi over 6. And what is the cosine of pi over 6? It's the square root of 3 over 2, and then I put the negative sign there. So the cosine of 7 pi over 6 equals negative square root of 3 over 2. Now the fact that I have these two values, I can figure out the tangent of 7 pi over 6. Because the tangent of 7 pi over 6 is the sine of 7 pi over 6 over the cosine of 7 pi over 6. So now I substitute in the values. The sine of 7 pi over 6 we said was negative 1/2, and the cosine was negative square root of 3 over 2. Now I want to simplify this. There's a couple ways to do this. Some of you probably have seen that I can multiply by the reciprocal. Let me show you the way I would do this first, and then we'll talk about doing it that way. What I would like to do is multiply both the top and the bottom by 2. So I can always multiply, anytime I have a fraction, I can multiply it by another fraction as long as the top and the bottom of that new fraction are the same. So I'm really just taking my original fraction, multiplying it by 1, because 2 over 2 is the same as 1. Now when I do this, then what do I get on top? I get negative 1/2 times 2 over negative 3/2 times 2. Well, the negative 1/2 times 2 on the top becomes negative 1, and the negative square root of 3 over 2 on the bottom. If you want to, you can put a 1 down there under each of these. I do multiply the tops across and then the bottoms across. I'm going to get negative square root of 3 because, let me just show some details here. These 2's cancel out, and so then I get negative square root of 3 over 1, which is the same thing as negative square root of 3, which is what I got here. And on this side, I get the 2's cancel out, and I get negative 1 over 1, which is negative 1, which is what I got over here. So we have, also I can cancel out the negatives, so I get 1 over square root of 3. Now, some of you were probably taught in high school or in middle school that you can't have a square root in the denominator. Well, that's wrong. You can have a square root in the denominator. There's nothing wrong with it. So you could leave your answer like this. However, if you don't want to do that, we'll just go through the steps. What if I wanted to change this answer so that I didn't have a square root in the denominator? Well, I would multiply this fraction again by 1, and I write that 1 as the square root of 3 over the square root of 3. And when I do that, then on the top I have the square root of 3, and on the bottom I have a square root of 3 times the square root of 3, which is the square root of 9. That's 3. So you get square root of 3 over 3. So I can say that the tangent of 7 pi over 6 equals the square root of 3 over 3, or I can just leave it as 1 over the square root of 3. Either answer is correct. So we have these other trig functions. Besides sine and cosine, we have tangent, we have cotangent, we have secant, and we have cosecant. The next idea is that there are some trig identities. Now, there are a whole bunch of trig identities. There's hundreds of trig identities. Do you need to know all hundreds of these? No. I will share with you what I consider the most important ones that you need for calculus. So number 1, you should know that the cosine squared of x plus the sine squared of x equals 1. Where does this come from? Well, remember, we're dealing with a unit circle here, right? And we've got a point on the unit circle, okay, of radius 1. This length down below here is the x value, this is the cosine x value, and this is the sine x value. Now, using Pythagorean theorem, then what I have is a right triangle where this is cosine x, this is sine x, and this is 1. And so by Pythagorean theorem, we have cosine x squared plus sine x squared equals 1 squared. Well, when we write cosine x, everything squared, it's common to write that as cosine squared x with the 2 in between the cosine, the cos, and the x part. Likewise, for sine x quantity squared, we usually put the 2 in between the sin and the x. And that's where we get this first identity here. The second identity that is used is 1 tangent x squared equals secant squared x. Where does that one come from? Well, suppose we started with cosine squared x plus sine squared x equals 1. And let's divide everything by cosine squared x. So I have cosine squared x over cosine squared x plus sine squared x over cosine squared x equals 1 over cosine squared x. Well, what cosine squared x over cosine squared x equals 1. Sine squared x over cosine x, that's the same thing as sine x over cosine x, everything squared. And sine over cosine is tangent, so that becomes tangent squared x. And 1 over cosine squared x is 1 over cosine, which is secant. But I have 1 over cosine squared x, so that's going to be 1 over cosine, everything squared. So I'm going to have secant squared x. So that's how we get the second identity. The third identity is that the sine of 2x equals 2 cosine x sine x. In fact, this is a specific case of one that I think it would be good for you to know, and that is the sine of x plus or minus y equals the sine of x cosine x plus or minus the cosine of x sine of y. Now, when I say plus or minus, what I mean by that is if I have a plus between them, then I get a plus. I have a plus between them on the left side, I get a plus on the right side. And if I have a minus between them on the left side, I get a minus on the right side. And then the next one that you should know, and we'll say this is the last one. So these are the top 5. So if I have cosine of x plus y, that's going to be cosine x cosine y minus sine x sine y. So just emphasize that. If I start with a plus between them, I get a minus. And what happens if I had a minus on the left side, then I get a plus on the right side. So those are some of the main trig identities. Let's do an example of how you could see a problem with this. Let's look at this example. If this example has, if the sine of x equals 3/5 and the cosine of y equals 1/2, where x and y, so we're going to have x and y lie between 0 and pi over 2. So those are angles, they lie between 0 and 2, 0 and pi over 2. So they're in the first quadrant. Evaluate the expression of sine of x plus y. So this is hard because I don't know what x is and I don't know what y is. I just know that they're somewhere in the first quadrant. So I'm going to have to use one of the identities. There's an identity that tells us what sine of parentheses x plus y close parentheses is. And that is this fourth identity here with the plus sign in between. So I get the sine of x cosine of y plus cosine of x sine of y. Again, that comes from this fourth identity that we just talked about. Well, we know that the sine of x is 3/5. So this is going to equal 3/5 here times, and we know the cosine of y is 1/2, so we get 1/2 here. But we don't know what cosine of x is, and we don't know what sine of y is. So we need cosine of x and sine of y. Well, how do I do that? Well, this goes back to something we mentioned in the first video on the trig. So for cosine x, we know that the sine of x is 3/5. Why are we picking that one? Well, it's because they both have the angle x here. That's what's important. All right, so then I draw my right triangle. This is my angle x here. And because we have the sine of x is 3/5, and we know that the sine of x is going to be opposite over hypotenuse, I can let the opposite be 3, right? This opposite is going to match us, and then I'm going to get the hypotenuse is going to match the 5 here. So I can put a 3 and a 5 there. Now again, it doesn't mean that they have to be 3 and 5, it's just the ratio of them, but this is okay because we're taking the ratio of everything. And I'm going to let this last side, the adjacent side, be a. And then by the Pythagorean theorem, we know that a squared plus 3 squared equals 5 squared. So I get a squared plus 9 equals 25, or a squared equals 16. I take the square root of 16. That means what number times itself is 16. It could be 4, -4, but we're only dealing with positive lengths, so we're going to say a equals 4. And so what is cosine of x? Cosine is adjacent over hypotenuse, and the adjacent now is a, but we figured out that that was 4, so we get 4 over 5. So cosine of x equals 5. So we can put So we have 4 over 5 up here. Now we need to figure out what is the sine of y. For sine of y, we know what? Well, we go back to our original ones, and we have cosine of y. We know cosine of y equals 1/2. Again, we pick that one because they have the same angle y here. So I'm going to draw my triangles. The different triangle, although they may look the same, but now I'm looking at the angle y. And I know cosine is adjacent over hypotenuse, and I know the cosine of y is 1/2. So I'm going to say the adjacent side is 1, the hypotenuse is 2, and I'm going to put a b for the opposite side. And so by Pythagorean theorem, we have here that 1 squared plus b squared equals 2 squared. So I get 1 plus b squared equals 4, b squared equals 3. And in this case, when I take the square root, I'm just going to get b as the square root of 3. There's no way to simplify it from there. So then we're trying to figure out what sine y is, which is opposite over hypotenuse. And we saw that the opposite side now here is square root of 3, and the hypotenuse is 2. So we get that number there. So we're going to go back and plug this in. We have square root of 3 over 2. Square root of 3 over 2. So let's write that, what we have up there, let's write that down here. We have the sine. We were looking at the sine. Originally we were looking at this part here. So I'm going to copy that down here. The sine of x plus y equals the sine of x times the cosine of y plus the cosine of x times the sine of y. And we had the sine of x was 3/5 and the cosine of y was 1/2. We figured out here that the cosine of x was 4/5 and the sine of y was square root of 3 over 2. So now we multiply these. For the first fractions, I multiply the top together and I get 3. Multiply the denominators and I get 10. For the next part, I get 4 times the square root of 3 on top, which I just write as 4 square root of 3. And in the bottom, I get 5 times 2, which is 10. And then I can write this as 3 plus 4 square root of 3 over 10. And that's as far as I can go in simplifying this. Let me do another example here using these trig identities. Let's say the problem is find all values in the interval 0 to 2 pi that satisfies the equation 2 sine x minus 1 equals 0. So the fact that we have the interval from 0 to 2 pi just means that we're dealing with going around the circle one time. What I want to do is I need to figure out the x value. So that means I need to try to isolate sine x by itself and then use that to try to figure out what the value of x is. So we have 2 sine x minus 1 equals 0. What I'm going to do is bring the 1 onto the other side. So I get 2 sine x equals 1. Let me change, my tip of my pen is wearing out. So let me change that here. So I have 2 sine x equals 1. Now I'm going to divide, let's see, sine x equals, if I divide both sides by 2, I get 1/2. Now when does the sine of x equal 1/2? Well, let's go back to our circle. If we memorize those values here, at pi over 6, then I have the sine of pi over 6 equals 1/2. That's going back to that chart or table from the very first video. So I know that x equals pi over 6. But that's not the only time it equals, that the sine of an angle equals 1/2. Where is the sine a positive number? It's positive in the first quadrant and the second quadrant. So we look at the equivalent of pi over 6 in the second quadrant. That's over here, and that's going to be, if I go all the way around, that's 5 pi over 6. And the sine of 5 pi over 6 also equals 1/2, because the sine of pi over 6 is like the y value, how high it is above the x-axis. And in both the first and second quadrant, it is above the x-axis, not below the x-axis. So the answer would be, in this one, x equals pi over 6 and 5 pi over 6. And we can write it like this. These ones can be a little bit tricky, so let me do another example like this. Here's this one. Find all values of x in the interval from 0 to 2 pi such that the cosine of x equals the sine of 2x. So let's look at the solution here. So this one's harder than the previous one. Now, when I've got both of these terms, one on the left side and one on the right side, I'm going to bring them all over to one side so I can set it equal to 0. So I'm going to get the cosine of x equals the sine of 2x. That's the same thing as saying the cosine of x minus the sine of 2x equals 0. Now, why do I do that? Well, is there a trig identity I can use? Well, I know that the sine of 2x, there was a trig identity for that, and that identity was that the sine of 2x is 2 cosine x sine x. It may have been written as 2 sine x cosine x originally, but it doesn't matter whether I put the cosine x first or the sine x first, because you're multiplying them. It's like saying 3 times 4, it's the same thing as 4 times 3. So cosine x times sine x is the same as sine x times cosine x. Now I look at this, and what's nice about this is both of these terms have a cosine x. So let's factor out a cosine x. So if I factor out a cosine x from cosine x, I'm left with 1, because cosine x times 1 gives me cosine x, right? Cosine x times 1 gives me cosine x. If I factor out a cosine x from the second term here, the 2 cosine x sine x, I'm left with 2 sine x. And now what's nice about this is I have two numbers, or two terms, expressions, that multiply together equals 0. So if I have two numbers that multiply to equal 0, what do I know? Well, I know that at least one of them has to be 0, right? Think about it. Can you multiply two numbers together to get 0? The only way you can do that is if at least one of those numbers is 0. So this means either cosine x equals 0 or 1 minus 2 sine x equals 0. So let's look at the first case. If cosine x equals 0, when does that happen? Well, I go back to my circle here. Cosine x equals 0. I think we can go back to that chart here. At pi over 2, I get the cosine of pi over 2 equals 0. And this makes sense in the diagram because cosine x, remember, is the x, it equals the x value on our axis here. And if I go straight up to a straight vertical line, the x value is still 0, right? What's the value of this point on a unit circle? It's 0, 1. And this first 0 represents the cosine of pi over 2. Is there another place in this on the circle where the cosine of x equals 0? And yes, there is. And that's straight down right here. And this is at 3 pi over 2, because the value there is 0, negative 1. And so the cosine of 3 pi over 2 also equals 0. So when I say the cosine of x equals 0, that means that gives me x is either pi over 2 or 3 pi over 2. So that was the first one we did here. Now what about the second one? The second one we had was 1 minus 2 sine x equals 0. Well, if I multiply everything by negative 1 here and rewrite this, or it's the same thing, I'm going to use this little double arrow. That means it's the same thing as saying 2 sine x minus 1 equals 0. If I take what I have on the left here, 1 minus 2 sine x equals 0, multiply by everything by negative 1, I get negative 1 plus 2 sine x equals 0 times negative 1 is still 0. And then if I switch the order, I get 2 sine x minus 1. So those two are equivalent, but we just did this one. This was solved in the previous example. And in that example, we go back up here. Remember, that was this one. And what did we get? We got pi over 6 and 5 pi over 6. So here we get x is pi over 6 or 5 pi over 6. So the final answer is a combination of these is x is pi over 2, 3 pi over 2, pi over 6, or 5 pi over 6. I'm going to stop there with this second day of review on the trig functions. Hopefully this is helpful, and have a great day.